semester is almost 50 names. It's a lot of students in this class. All right, so now for that chapter that we're going to learn this SPEEMs. Everybody installed the SPEEMs in their computer? It's kind of necessary because you need to learn these tools. It's a programming language. It's kind of a compiler, assembler, you can call it, not a compiler. It's like assembly, part of assembly language tools, MIPS. MIPS assembler, simulator, basically. It's not the real assembler, but it's a simulator. So it is a simulation environment. So everybody installed, yes or no? Anybody not installed the software?
What's the name of the software again?
SPEEM. Qt SPEEM, actually. Qt SPEEM. Says Qt. You can search it. So Google it. Qt SPIM SPEEM. SPEEMs. Yeah. So that's actually this software that I already have. Where is the SPEEM? Let's search it. Qt. Yeah. SPEEM, SPIM, actually together, not separate. So you go to the source ports link, somebody put a link there. Source ports and download from there. That's the real one. Okay. So if you look at my screen, I'm sharing it. So this is how it looks like when you open up and run a code. All right. So
Excuse me, Professor.
we'll have an assignment. Question?
It says I need permission to record. It's not letting me do it.
Yeah, we just record it. If you want to record it, record it.
When I click the record button, Zoom says I need permission.
Huh? It doesn't allow you?
When I click the record button, Zoom says I need permission. Please ask the host to give you permission to record, it says.
Yeah, but how do you do that? Let's see. I can record it, but for you, record on this computer, cloud, no, I don't want to do that. Where's the permission? Security, maybe? Yeah, let's see. Let me put it in system, work meeting, share screen, start video. No, it's not on the security option. The permission thing. It should have permission. Let's see if we give the share permission. Share permission is in this. Let's
Hello. Pretty good. Do you? All right, don't. I want him not to join. I want him not to join back.
Me too. At me when he's back, man.
Are you gonna go play Valorant or something?
Hell yeah.
Oh my god.
And I'll go to your house after. You guys want to start the homework later after this class, maybe? Or whenever.
What? What'd you
Those
say?
guys said the homework for this class takes like 5 minutes.
Well, I looked at it. It should take like 5 minutes. It's just converting to the different number
Okay.
systems.
Uh,
Kinda feeling like this professor's incompetent. Even if his Wi-Fi did go down, just he would send an email to us through his phone, right?
It's just the fact that that student was literally requesting to record on his own end. And of course it's gonna give you a message that of course it's gonna say that, you need permission from the host to get recording privileges. Of course it's gonna say that. And then he literally goes ahead and does that, and then I guess it gave the student host privileges and then it kicked him off somehow. Like what the heck?
Trying to play Valorant with these people, but they're not saying anything, bro. Come on.
Play Valorant with the professor.
Imagine.
I just
I
stopped.
really don't get.
Alright,
I
I
don't
guess I'm
get
playing
why.
Arctic Phone instead. Nobody wants to play Valorant.
I don't get why he hasn't sent an email out.
Maybe he thinks he can figure it out, but I don't know.
Prof. Full nickname
What
9.
a mess. This class is a mess.
It is a mess.
And that's an
Oh,
understatement. This is a mess. Oh,
And just play some Arctic Phone,
my
guys.
goodness.
This is great. We're having a
This
great
is
time.
great. How's everyone doing? Did you have a nice weekend?
Mhm.
Yeah.
That's good. Pretty unproductive.
My browser froze. Did the game start?
No.
Okay, I sent it. I just thought he checks it because his email goes off sometimes, and I don't know if he checks his emails in class.
Okay, well, at least we made an attempt, and that's all that really matters. Thank you.
The effort
Yeah,
was
no.
made.
Yeah.
Some profs have their phone numbers in their syllabus. Does he?
Yes, let's call the
I could
professor.
I
right
don't
now.
think so.
Spam call him.
Do we have a Discord
yo.
for this class, like a official one, or
Yeah.
Yeah.
Well, what do you mean
Set
official?
up a
Or not
Gartic
official, but
phone
like a
lobby, and you'll also join the links in the
Like
chat.
class one?
Yeah.
Yeah.
yeah, class one?
You want in?
I'll send you an invite.
Okay.
Unless if I'm already in, I'm probably not in though.
What?
Where'd you get the homework again?
Yeah,
You
I'd
didn't
love
get
to
it?
teach the class how to do all this
I thought
stuff,
you got
but I
it
don't
from-
know any of it because
I just
haven't
found it on
learned it yet.
Island.
So
On where?
Wait,
Island.
wait,
Oh,
you're
wait,
the
I-
host.
Am I
You
in?
got
yeah.
this.
Oh, sorry. I should
Oh, I am
probably
in.
be
Is
lecturing
it-
everyone
yeah,
right
I'm
now,
in.
huh?
Yeah.
Okay, learn what? Learn what? What are you talking about right now, bro?
Oh my goodness.
Wait, isn't this
Guys.
learning how to draw 101?
Basically.
I don't know why I can't invite you. You must be already
oh
in
my
it.
god, Gartic Bone sponsored by Nick Guru.
Yeah, this is the off-stream version.
You better stream this right. Stream
is-
this right now, bro. Stream this
Nick
right
Guru,
now.
the
Bro.
Twitch streamer.
This is just for you guys. This is
Okay, okay.
the private lobby.
It's school. I'll be famous. I'll be featured on Twitch. No, I'm not playing though.
Exclusive content right here.
It's an honor. Big dads.
Oh, who left, bro?
Someone just didn't give themselves a nickname.
What's going on? Why is it losing players?
Someone's nicknamed Prof question mark. Is that where the professor is?
Yeah, basically.
sentence. Oh my god.
Hey, yo, can you guys hear me?
Yeah.
Yes.
Okay, cool.
Did the game start yet?
Yeah, the game started.
What? No,
yeah,
it didn't.
we're writing the sentences right now.
You're lying.
Did you guys join the Gartic phone?
Yeah, we're in the
Yeah.
Gartic phone right now.
You're lying.
Streamer, man. Gooby.
Yeah, we're sponsored by Nick Guru, man.
True, true.
I'm refreshing.
Wait, is he actually streaming on Twitch?
Wait, no way. Nah, I don't think so. He said he wasn't streaming.
He said
said
this
it was
is a
like a
private
lobby.
lobby.
Fries versus what? I shouldn't have said anything. Hey, Steven, you're the only one in here, though, right?
By the way, if you're in the lobby, the game has started.
I don't think I'm in.
You're not in?
It didn't start for me, then I refreshed. Now I'm not in.
That's an L, bro.
Someone share their screen.
I got you. Oh, fuck, I have Valorant on. I gotta turn that on. I thought we were gonna play Valorant, and then nobody responded. So sad. That's it, bro. I don't know what to do.
Hello. What's not working?
Yo, how long has the teacher been gone?
I haven't been keeping track. It's been eons since you last left. What's not working? Did the Steam is not installing for Elisa. I don't know what the problem is.
What, spin?
Yeah, Steam.
Steam.
Are going to install Steam?
It installed in like 2 seconds for me.
Yeah, I don't know. I had no problems. Also, your audio is a little low, Andy.
I know.
Unless that's
I have it on max though.
I have you
Actually,
on
no, it might
max.
be. It might be my compressor, but then if I turn it lower, then you might be able to hear background noise.
Oh.
Is it better?
Anything? It's about the same.
About the same.
Man, we were all not very original with our prompts.
Anything I can help you with, Elisa? Or what's happening? Oh, you're good? Okay, since you have Spim installed, now you can go ahead and work on those exercises that the professor put in the PDF. Chapter 2.
Lol.
How does my audio sound? Is it alright? Is it too low?
Sounds pretty good.
Oh, he's back.
Oh, he's back.
Oh.
So you couldn't hear me for a little while.
It's been
I
like
didn't
20
even
minutes.
A
Though.
realize.
while.
Alright.
So I was disconnected.
I think you've been disconnected for the last 20 minutes.
20 minutes?
Yeah.
My God. Keep talking.
Right after you gave permission to record, that's when it cut out.
Oh. Yeah. I don't know. I don't know why. That's, so I was going through that. I didn't realize that actually. I'll just keep talking. Okay, so you've gone through that part, that assembly part. That's, I think was this, yeah, this part. So we went through that. Now I was going through this. So all these registers. I'm sorry. So we have 32 registers. We said here 32, 0 to 31, and some of them reserved. So 2 of them is reserved, 0 and 1, and then you'll see we left with 30, and they're alternate names. So that's why I see in the code what happened.
Did you share your screen, please, Professor?
Huh? Hang on. Suddenly I lost my screen. Okay. Can you see my screen now? Can I see your screen? Yeah. All right. So this, the registers. So 0 and 1 is reserved, and then from 2 to 31 we can use to write the code in MIPS program. And they have alternate name. And that's why you see that in my program here, I use this LI and then V0, register V0, A0, V0, A0, S1, V0, A0, V0. So all those registers we use, we didn't use this $8, $15, $4, $7. We didn't use that. We used the alternate name. It's the same thing. Instead of writing $4, $7, you just write $A0 to $A3, A1, A2, A3. So the same thing, $4, 5, 6, 7, A0, A1, A2, A3. Writing the same thing. So you see in the code that I have this, you put V0, A0, but the actual is not V0, it's actually $2. So that's the register, second register. So when you see the V0, $V0 is basically $2. I think they use this kind of symbol to better remember that you mix up with actual integer with these registers, you may mix up with that. So that's why, like here, when we have V0, 4, if we have so the V0 stands for what? V0 stands for $2. So if we write $2, 4, if it happens to be 4 here, but if we have something like, it's like 7 here, but if we put 2 there, then it'll be confusing. So that's why I think they use this A0, V0, T, S1, those kind of symbols for the name of the registers. Okay. And this LI, load immediate, load address, those are the actual operand, like command, like add, sub, that kind of command. Okay. So we went through this chapters the other day. I'm just reviewing it again. Hopefully I'm not missing it again. So as we see that the CPU has quite a few things. We have registers, we have a program counter, we have an arithmetic logic unit. So this is the thing, it's connected to a bus, and this is the input output device on the side, and this is the registers, all these registers on the right side. Sorry, it's not register, it's memory. I think. This is memory. These are the registers in the CPU. So you learn about this, the addition and subtraction, how it works in assembly language. So you'll see that there. And the load and store architecture, they call it. So you load from the memory to the register and send it to the arithmetic logic unit, do some calculation and put it back to the memory. So this is how they call it load store architecture for MIPS. A good compiler will try to allocate frequently used variables to registers. So if you use the variable whatever frequently you use the register, because they're fast. Advantage, fast access, less code. Disadvantage, may not have enough registers for all variables. So just try to remember this, very important for your test. And then we looked at this symbols. This is how the structure is for writing program. And we have this same example here, similar. Dot data, dot text, main. So it's 3 parts of the program. So you can try it. You can try it in your SPIM and see how it's up. SPIM has this part. You see that. So you can see that here. So this is the text part. This is the code part that we typed in, like li. Not start from this. It's just from here. Syscall 7 1 4 to v0, then the string name, load a, and then 4 again another string course, and then 7 integer number, and then 1 to get the input, and then move, and then syscall. So all this code we wrote on that piece is there. But then when you run it, you have captioning. And then when you run it, you see this output in the console. As you see in the console, you see the output there. So now, I'm not pretty keen on writing a lot of programming the assembly, the MIPS code, but have a clear concept like how this thing works. Some examples there, so I should read through this. For examples in the slides, and important piece is this, that you need to remember that actually, in order to print something on the an integer on the screen, you need to load 1 to v0. Load 1 to v0, and then move this, and it will give you that. And then if you want to do reading integer from a screen, then you have to load 5 to v0 first, and then you can move your stuff v0 to s0. S0 is your data, holding your data, and then you can get in from the keyboard. For a string, you have to use this dot data and str, that's your string, colon ASCII z, dot ASCII z, ABC is your string, and then you load v0 to load 4 to v0, and then you load address from str f0, and then syscall, that will give you a string on the screen. So like that, you have lots of examples here, like the branch equal to. So if you, any programming language, so use if something, then do something. So here, you don't have that if, but you have to use this branch equal to. Like if S0 equal to S1, then go to label, go somewhere. So that's that kind of thing, your operator is BEQ. So like that, if you look at the green paper, we have actually lots of symbols here. So you can see what they do. All sorts of symbols here. So that BLT, branch less than BGT, branch greater than BLE, branch less than or equal BGE, branch greater than or equal LI, load immediate, move. So this is the command, mnemonic like symbol they use instead of using if then else statement. Okay, so there's a certain way to doing things in MIPS. So just go through those examples and try to understand that, and then we'll go from there. So you can try it out, some simple example in the MIPS simulator, and exactly see how it works. Like here's another example here. So we have a loop here, for loop. See that on the left side, the C++ or Java code, and then right side you have this assembly language. So for loop, we can use do while loop, all that, okay? So I think we'll stop there, that part, and then we'll go to the next chapter, pointers and arrays. So how do you deal with pointers and arrays in MIPS? That's the another question here. So there are a specific way to deal with that. Pointers and arrays. So here's some example. You have let's say you have a program, integer x equal to 4, integer y equal to -1, and then you have a code and do something with it. So to do that in assembly, you have to say dot data x is a declaration, a dot word for y colon dot word -1. That's exactly this. Integer x equal to 4, integer y equal to -1. To declare this, you just use these kind of symbols in MIPS. And then you have main programming and do stuff. And then address memory. Okay, let's try an example maybe. One moment. Let me connect to the pad. Share a screen. So in order to, let's go to the OneNote. So you see my OneNote screen? Yeah. So now, let's say, for example, we want to do some addition or multiplication. So we have, let's say, integer 2 and another integer number 5. We want to have a multiplication. I want a product. Okay, so multiplication. So in multiplication, you use mul. That's the operator you use for multiplication. Now, how do you do this? Now, what do you do for the assembly language? First, you need to load this in any register, and load also this. This is a number, direct number. It's not a variable. This is a direct integer number. So load. You have to use the load immediate. So in order to do this, what do you do? So you have to say li, and then you have to have a register to load it. It's a T1 or T0 temporary register. And then you get a comma, and then you can use another register, but I think you don't have to. You can just directly load that number to there. So load these two. And then another load instruction, let's say we use T1, reach T1, comma 5. Now you do this small, and then so for multiplication, you need a 3 register. So you put it on, let's say you're going to put T0 up T3, and then your T0, comma, whatever is in a T1, that's it. So now this is your results, T3. So when it has a load immediate, you just put your integer to a register, another register, and then you mark. So this is how you do the multiplication. So if you have a question that says that, show me how you can multiply 5 times 2 in MIPS language, then you have to do this. But in order to do that, you need to do this kind of coding in MIPS. Dot data, nothing, and dot name. You can have a string, and then you can do this calculation and give the output to the screen. So if you're going to put output on the screen as a string, then you use that string here, and then you call it, and then you put this results, multiplication results to the screen. So that's one example. So pointers and arrays, I think you can just read through it. I will not give you any assignment on that. But there's some other command like this store word, is an example here. And when you see this -4 times that contents of the register, means you go 4 times lower or upper. So add or minus through the registry. So read through this a little bit. Some of them is not very clear, kind of confusing, but read through this, but I'm not very keen on those. But as pointers, if you learn the C or C programming language, then you've heard about pointers. And the pointer is kind of a variable that contains another variable in the memory. So that's what it is. So the example you'll see here, x is an integer variable, okay, just a variable. Pointer x is a pointer to an integer. And then S0 register is also a pointer to an integer. So those registers works as a pointer. So it's just a location pointer, not the actual value. Actual contents is whatever you store into. But S0 itself is just a kind of a variable pointer. So this is, you have an example here. Pointer x and S0 both point to x. Pointer x and pointer S0 contain the address of x. Contain the address of x. Both. This is address of x, address of x. Declaring pointers, how do you declare a pointer? So you have to have this type. What type of pointers? Pointer can be char, can be integer. So you have to say integer, and then you put asterisk, and then name of the pointer. This is a pointer to an integer. And then you have a char, then like this, you have this PTR0 or PTR1, it can be anything, but this asterisk sign is required. to say the assembler that this is pointer, this is a character pointer to a char, pointer to integer. And then you can initialize value of a pointer using this n%. X means address of the variable X. And here you can assign that value. Let's say you have a integer pointer X and X2 here. So you have an integer pointer, you declare that, and then you have actual integer X, and then pointer X equal to, you can write the address of X. So this is an integer, this is pointed to that integer. And you can assign that pointer X equal to address at person X, address of X basically. So just read through this and try to understand it, and you can see some example in C and to get a clear idea. But then assembly language is different, and you can see the contents and all these variables, and we'll see some example. Vectors array. Using pointers to access char arrays. How do you do that? So here's some example. So we have this pointer char, address of the string, location 0, and simple pointer arithmetic. How do you do this? You can add in something to a pointer as well. So I'm not very keen on test on you on this pointer stuff. Just read through it and try to understand if you can. But and MIPS. How do you do in MIPS? Do it like this. Very different. So you have string and dot byte 0 to 6. That level string allocate 6 bytes. And then you put this 0 to I, register I, and then a string to the base, another register, all that, and you have a loop. And in the loop, you put this addition, and then you call this loop here. It's less than, so the branch less than sign here. Yeah, so this is a C++ example, and that was the MIPS example here. See here, for loop, use this loop. This is a string, this is a pointer, and this is a string, and this is how you do in assembly, exactly the same thing you do it in assembly. So not very straightforward, but you can get it. You try assembly and C. So there's those examples here, assembly and C. Just go through those and try to understand, but I will not give you any test on this. But what I will test you on, like, understand simply how you can load a number, integer number, and do this subtraction, addition, and multiplication or remainder operation. And that's the main thing. And also how to print an integer on the screen, string on the screen, or get input from the user. That kind of concept we talked about before. Okay. So that's important. All right, so this is the summary of this: the load word and store word, and load byte, SB, store byte, load address. Just read through the this code and some examples. This, especially the last couple of examples, that the C and MIPS examples. just try to understand this. And that's that chapter. The next chapter. So let's look at the next chapter. Is function. I think we will talk about this function in next class, stack and function. Not very much. I think we should do some exercise on this beam. Let me see some, okay, so stack and then chapter 4 we'll talk about in next class. So this class, we still have some minutes. So let's look at the this beam. Some other examples I have. Let's see. Initialize. Load. Let's look at this. Next one is reserved for assembler on line 3. I don't have anything on 3. I think it's some issue there. So let's try another one. This one. There's no complaint on this one, please. That's execution error. So let's clear the registry. Yeah, the simulator is not very friendly. It says attempt to execute non-instruction at 0040038. What non-instruction are you talking about? So this code, let's look at the code. What is there? I try to there. Yes, probably here. Where's these files? Let's see. So it's 256, then CSC 256. Should be here. Yes, and look at this one, the temp. What is in here? You try to do, okay, first word, text, main. Should work though. So we have three words, and then we try to load word on the first one first. And then I try to add 431. Yes, should work, but it's not working for some reason. Try the other example. Last one. Look at the console. Nothing shows up. There should be a prompt to do something. The last one. Yeah, so this one not giving any results. Well, it should be data prompt, ASCII Z message, and then main, and then we have all this. Let's run this so we can see what's going on there. The test prompt. So here is probably an error here somewhere. So let's clear the registry. Initialize. And load it time. And run it. It's running. It's running. Then its console should give me some prompt, but it's not showing any prompt. Because if you look at this code, it should give this enter your age is whatever, and then do something. For some reason, it's not showing up there. I don't know. Okay, try on your own. Let's type this up, type this code in your computer and try to run it from your settings.
We type this in a notepad and then make it a .s?
Yes.
Okay.
Just open it, a notepad file. Just copy this and try to run it. It was running before. I think something happened to my
Try it.
software. Give me 1 minute. So you can see the code.
Yeah, I'm still typing it.
Yeah, take a picture of it and run it and see how it works. If we can finish it, fine. If not, then we'll look at it next week. See what's going on there. So you're declaring two string variable by prompt colon ASCII and then the string, and then dot text, and then main. We're just Actually, hang on. I think this prompt is blocked here, but message is there though. No, it's all blocked actually. Oh, see that? Yeah, all is hashed out. Let's change that hash. I think some reason I did that to test something. Well, let's see.
Because hashtag is common.
Yeah, it's a comment. So I commented out some reason. I don't know why. Let's try now. Save it. Yes, should give us some prompt and some data and display those data somewhere. Yeah. On the console. Okay, let's run again. We will clear the registry probably. Clear the registry. Clear. And initialize and load. And then run. It's running. So where is my console? It's in the bottom. Yeah, here it is. So it shows up. Enter your age. It's running. That's 30. Wish. No, it says your age is 30. Okay, it's showing up. That's the only thing, one, but we have two actually, isn't it? We have two messages in the code. So we have, okay, prompt is, oh, it's correct actually. That's what we are doing. So we're getting a age as a prompt, and then we're displaying that the US age is 30. So that's exactly what we're getting from the console. Yeah, it is. Your age is 30. Your age is 30. Twice. Oh, so after I put this, and then it says age is 30. I enter erase and then erase. Correct. So it's working. So it's working fine. But so initially I blocked it for some reason to show something else. Probably so that's why it was not working. So try something like this program, and then we'll we have an assignment working with this MIPS simulator. And it's pretty kind of basic to me. I mean, it's not sophisticated enough. But I think you can do a lot of stuff using this simulator. But we don't have any project as such in this, but we'll have a small assignment for the next one using this Qt Speak. And then we'll, next thing we learn another software called LogiSim, but there's some other chapters. Let's see. I think we run out of time almost. So we'll end here. We'll not carried away like the other day. So type this up and try it on your own computer, see if it's working. And we will go from there.
Quick question. You want us to take a picture of it right now, or will it be posted on either?
Just take a picture or just.
Okay.
Yeah, take a picture now. I'll give you right now. Yeah, this is it. Just take a picture. Just very simple thing, but you may need the code. So take a picture of this and keep it, type it on your own computer and try to run it using your SPIM, and we'll check it next class, whether it's working or not.
Okay.
Okay. All right. We can create some other examples and try it and share with the class. Yeah. But we will have a homework soon. All right, so let's stop here and see you in the next class.